Before we get into our discussion about loops, let's talk just a minute about relational operators, because they're going to play a role in loops. We use these all the time in real life. We can say, my score is greater than your score, or his GPA is less than 3.7, or this dog's weight is at least 15 pounds, things like that. So we're going to use relational operators in much the same way in programming. There are only 6 of these relational operators, and they cover every way that you could compare numeric values. More about that in just a second. What you need to get used to thinking of is these give you a true or false result. In my example here, if x is less than or equal to y, that's going to be true only when x is smaller than y or x is equal to y. If x was greater than y, then my statement on the screen would be false. Here, this will be true when value 2 does not equal value 3. Otherwise, it'll be false. In the next example, this will be a true statement if num1 is greater than 7.392, and it could be a float or a double. This one will be true if score is exactly equal to 98. If score is something other than 98, that'll be false. But this last one is not a relational operator. It means store 98 into the score variable. Take a look at these two. The top one is testing to see if score equals 98. The bottom one says store 98 into the score variable. They're two completely different things, and people get them confused all the time. Please watch this program run, and then we'll talk about it. My program asked me to enter pairs of numbers 4 different times. What made it do that? The answer is I'm using a while loop. Take a look at line 15. Inside the parentheses, you'll see something that evaluates to either true or false. And the while loop acts like a gatekeeper. It says, as long as that condition inside the parentheses is true, I'm going to execute the code that's inside the loop. Notice the way I declared my n1 and n2 variables, 0 and 10. When I add them together, I get 10, which makes the condition on line 15 true. It is true that n1 plus n2 does not equal 100. So the loop executed and asked me for the first pair of numbers. I entered 45 and 10. The loop goes back to the top. Is it still true that n1 plus n2 does not equal 100? Yeah. 45 and 10 don't equal 100. So it asked me again. I entered 98 and 3. It goes back to the top. That gatekeeper always checks before executing the code inside the loop. I entered 68 and 22. Nope, you add them together, you don't get 100. It asked me again. This time I entered 75 and 25. The loop goes back to the top. It checks the condition. Is it true that 75 plus 25 does not equal 100? No, that's false, and the loop stops. After the loop stops, line 21 occurs, where it just prints out the numbers and says that they equal 100 when you add them together. Now, if I had entered numbers that added up to 100 the first time I was asked, then the loop would have stopped right then, and line 21 would have occurred. What if it took me 100 tries to get a pair of numbers that when you add them together you get 100? Then that loop would have repeated 100 times. What if I never entered numbers that would equal 100 when I added them? Then I would have an infinite loop. It would just go on forever. Notice on line 16 and on line 20, I've got curly braces. Those curly braces form what's called a code block. In other words, those 3 lines of code, 17, 18, and 19, are all grouped together and treated as one unit of code. So every time the loop runs, all 3 of those statements occur. If the loop doesn't run, all 3 of them gets skipped. Ask yourself, what made the loop finally stop? And the answer is the condition on line 15 became false. In other words, we had to get to a place where the statement N1 plus N2 does not equal 100 was false, because as long as it's true, the loop's going to keep going. You got to get used to thinking in those terms. On line 13, I defined my variables so that I would gain entrance into the loop. What if I changed them like this? I'll start N1 off at 40 and N2 off at 60. Let's run the program. It prints out your numbers were 40 and 60, and they total to 100. Line 17 never occurred, line 18 never occurred, line 19 never occurred. Why not? The condition on line 15 was already false. 40 plus 60 equals 100, and it's not true that they don't equal 100. So I didn't get into the loop at all. The loop checked the condition, it was false, and my program went directly to line 21 and just printed the output you see on the screen. So file that away. It's possible a while loop won't run even one time. Here's a case that it didn't. Here's another while loop. Notice I'm starting my N2 variable off at 1, and I'm saying on line 15, keep going as long as N2 is less than or equal to 4. Inside the loop, I ask the user for a value for N1, and then I print it out. And look on line 20. N2 is increasing by 1. So every time through this loop, N2 increases by 1. So we know that after 4 times of running this loop, it'll stop and then go to line 22. And line 22 is just there to show you, okay, the loop's over, we're past it. It's asking me for a value, I'll put 45. It asks me for another value, I'll put 67. The third time it asks me for a value, I'll put 0. And then maybe negative 71. The loop ends because N2 finally got to a number bigger than 4. What made the loop stop? The condition on line 15 was no longer true because N2 became 5. But let's change that last program up just a little bit. I'm going to take out line number 20. What does that mean? That means N2's value is always going to be 1. Watch what happens. Ask for a value, 4, 3, 87, 100, 24, 68, 28, negative 86. What's going on? This loop never ends. It's an infinite loop. Why? Because on line 15, since N2 never changes from 1, that condition is always true. Here's another example of an infinite loop. It's going to keep on going forever. Now, when this happens and you're in a loop like this, the way to get out of it in Visual Studio is to hold the Control key and hit C, and that'll stop the program. Now, this was a different kind of infinite loop from what we saw before. The first one was the user might not ever enter the numbers that made the condition false. Here, the condition will never be false, no matter what the user enters. This is a more insidious kind of infinite loop. Just make sure you know how to get out of it when you get into one, and you will get into one. So you as a programmer have to make sure that when you write a while loop, something inside that loop is going to have to change to make the condition at the top of the loop somehow become false. Otherwise, you'll have an infinite loop just like the one I showed you. Let's change this up one more time. I'm going to put the line that was in there back, N2++. That means add 1 to N2. But up here on line 15, I'm going to do something that you should never do. I'm going to put a semicolon. We get used to putting semicolons after a lot of statements. Don't put one here. Watch what happens. Now, it looks like the program is waiting for me to do something. It's not. we're in an infinite loop, and it might be hard to realize that you are. But look over at line 15. N2 at this point is 1 because of line 13. Line 15 says, while N2 is less than or equal to 4, just keep checking. And over and over and over, millions of times, it'll check to see if N2 is less than or equal to 4. And it always will be. Here's another infinite loop. Watch out for it. So what do? We hit Control-C. And that ends the program. So a while loop might not run at all. It might run an infinite number of times, or it'll run an uncertain number of times that you can't foresee, like asking the user to input some value. And that's the key to using a while loop. If you've got a situation in your program where you want something to happen, but you don't know how many times it's going to take to fulfill what you need, use a while loop. That's what it's built for. Let's take that last program and make just a couple of changes. I'm going to take line 15 and move it down here, leaving the semicolon. And up here, I'm going to put the word do. Now here's a second kind of loop we need to get used to. It's still a while loop, but notice there's a couple of changes. I start with the word do, and I end with the word while that does have a semicolon at the end. Let's see how it works. It ran 4 times. Let's trace through the logic. First of all, there's no gatekeeper here. We can enter the loop without being checked for anything. It's like getting into a club with no ID. So the first thing the loop does is print out, enter a value. Then we get a value from the user. It prints that value out, and then it adds 1 to N2. And now is when the condition gets checked. It gets checked at the bottom of this loop. So this loop says, is it true that N2 is still less than or equal to 4? Yeah, N2 is 2 at this point. So it goes back to the top of the loop, doesn't perform any check here. It asks for another value, gets it, prints it out, adds 1 to N2, which is now 3, and checks again. It keeps on with this process until N2 becomes 5, at which time the loop stops and we go to line 22 for the output. So what's the takeaway from this? Well, first of all, it's still a form of a while loop. So pretty much everything I said about a while loop still applies to this do while loop. For instance, this one can be infinite. Most of the time, you use this one when you're waiting for a certain condition to happen, and you don't know how many times it's going to take to make that happen. Something inside the loop has to change for the loop to end. Here, on line 20, we're adding 1 to N2. That's going to eventually make this loop stop. This loop stops when the condition becomes false, because it is a while loop. But there are a couple of differences. First of all, it checks a condition at the bottom of the loop instead of at the top. There is no gatekeeper. The second big difference is that this loop is always going to execute at least once. That's not true of a regular while loop. So when does this loop come in really handy? When you're asking the user for input, because you know you want to ask them at least once, maybe more times than that, but you know you want to ask them at least once for something. Let me give you an example. So maybe you need the user to enter a positive number. In your programs before, you could ask them for a positive number, but if they entered negative or 0, then your program might not work right. By using this loop, you can say, give me a positive number, you get their number, and then look on line 20. Line 20 says, keep this loop going as long as N1 is less than or equal to 0, which means if they enter a value that's not positive, the loop will go back up and repeat again. See, you don't know how many times they're going to take to finally enter a positive number, but they can't get past this loop until they do. Once they enter a positive number, then lines 22 and 23 create the output on the screen. Here we go. The first time I'll enter a negative number. The loop executes again. I'll enter 0. The loop executes again because 0 is not a positive number. I'll just enter another negative number. It's not going to let me out of the loop until I enter a positive number, so I'll enter positive 59. The loop stops because the condition on line 20 now becomes false, and I see the output down at the bottom of the screen. No pun intended, but let me repeat myself. I would use this loop when you're asking the user for values, because you know you want to ask them at least once. Here I'm declaring 3 variables. Counter, which I'm going to use as a counter for my loop. Total, which starts at 0. I'm going to keep a running total of the values the user entered. And N1, which is what I'm going to use to let the user enter their values. So I start counter off at 1, and then my while loop starts. And I'm saying there, as long as counter is less than or equal to 5, keep going. Inside the loop, I get a number from the user, and notice on line 20 how I'm adding it to the total. This technique lets me use just one variable for user input and use it over and over and over again. Because remember, that variable is just a place in memory to hold a value. On line 21, I'm adding 1 to the counter. The loop goes back up to the top, checks to see if the counter is still less than or equal to 5. So this is going to let me enter 5 numbers and total them all up. As expected, I got to enter 5 numbers. Line 20 kept a running total of them, and then the total prints out. Notice there were 3 key parts to my loop. First, on line 15, I started the counter at a number. Here I started it at 1. On line 16, I'm seeing if the counter still meets the condition that I want it to. And then on line 21, I'm updating the counter. So again, 3 parts: starting the counter to value, checking to see if the counter still meets the condition, and then updating the counter. Keep those in mind. In this program, a while loop is not the best choice. How come? Well, I know how many times I want to run it. It's not based on some indefinite number of times to get what I need. I know I want this to run 5 times. There's a loop designed for this situation called a for loop. It's going to do exactly the same thing, and here's how it works. I start by putting the word for. Now notice I'm saying for the counter starting at 1, just like I did before. I'm going to incorporate this idea of a while condition. And then I'm going to take line 20 and move it up here. And get rid of it down here. So you can see this for loop takes all the 3 main parts that we talked about before from the while loop and just puts them in one heading. It says start the counter at 1. That middle part says keep going as long as the counter is less than or equal to 5. And the last part says update the counter by adding 1 to it. Exactly what the while loop did. And it works exactly the same. Here's the order that things happen in a for loop. We start some counter variable off at a value. So we initialize it to something. That's the first of the 3 parts in the heading of a for loop. The next thing is the middle part of a for loop, which really tests the condition just like a while loop does. And if that condition is true, then we go to the body of the loop where the code is executed. after the body of the loop executes the code, then we do something to change that counter. It could go up, it could go down. Something's going to change that counter. It goes back to the top of the loop and checks the condition again. Notice it does not reinitialize the counter. It just checks to see if the new value of the counter still meets the condition. If it does, it goes through the loop again. And that process keeps on going however many times that you've got the counter set to run. Now, once the condition is false, then the loop exits, and whatever comes after the loop in your program starts executing. And that's what happened here. We started the counter off at 1. The next thing that happens is that condition check in the middle of the heading that says, is the counter less than or equal to 5 still? The body of the loop executes, and then it comes back up, and in this case added 1 to the counter. That's the third part of the heading. And that process continues until the condition in the middle of the heading is no longer met. Now you might be saying, this is a whole lot like that while loop. And I'm saying, yes, it is. Which means some of the things that are true about a while loop are true for a for loop. For instance, is it possible that we never get into the body of the for loop? Yeah, what if I started my counter off at 10 and I ran that program? Notice what happened. The loop got skipped. It just went right down and printed the total, which is still 0 because the user never got to enter a value. Why did it do that? On line 15, we're starting the counter at 10. The next thing that happens is it checks to see if the counter is still less than or equal to 5. And we see that it is not less than or equal to 5, it's 10. So we never got into this loop at all. Is it possible for the loop to be infinite, like a while loop? And the answer is yes. Here's a for instance. Let's start our counter off at 1 again. We're going to check to make sure it's less than or equal to 5. And maybe I want this counter to go down 1 each time. Now think about that. It's starting at 1, and then it's going to go down each time. Let's run that one. We have an infinite loop because the counter is always going to be less than or equal to 5 because it's starting at 1 and going backwards. So we can have an infinite for loop also. So you can think of a for loop as a specialized while loop because that's exactly what it is. You use it when you know how many times you want to do something. Here I can look at the heading of this loop and know that it's going to run 5 times. The loop is not based on some indeterminate number of executions, like a normal while loop. And you can make some of the same kind of errors with this for loop as you do with a while loop. For instance, what if I put a semicolon right there? What effect does that have? This looks the same. It says enter an integer, so I'll put 45. And then it just goes to printing out the total. What happened? On line 15, that semicolon said in the loop right there. So the loop actually happened. The counter went from 1 to 2 to 3 to 4 to 5 to 6. In other words, the whole loop ran, but we never got into the body of the loop. We ended the loop on line 15. So what was the body of the loop starting on line 17 just executed once. And we saw that in the program. I just got to enter one number because that came after the loop had ended. So don't ever put a semicolon out there at the end of a for loop either. Bad news. The last thing I want to mention is nested loops. This is when one loop is inside another loop. You have to be careful with these, and I'll show you why in just a second. Notice something else. I don't have to use curly braces if I'm only going to do one thing inside the loop. So on line 16, that for loop is the only thing inside the loop that starts on line 15. And line 17 is the only thing that's going to happen inside the loop that starts on line 16. So I can put curly braces if I want to, but I don't have to. That said, let's put them. And so it doesn't hurt to write them like this. Either way, if you're only doing one thing. So notice outer stays at 1 and inner goes from 1 to 10. And then outer goes to 2 and inner goes from 1 to 10. And then outer goes to 3, inner 1 to 10. Outer goes to 4, inner goes 1 to 10. That means each time the outer loop runs once, the inner loop is running 10 times. And I could get how many times the inner loop runs just by multiplying 10 times 4. Now we're going to use these nested loops when we get to two-dimensional arrays. That's coming up in a few weeks, so just kind of file this away for right now. That's going to wrap up our look at basic loops. You can do all sorts of things with these loops, and the textbook goes into details about that. But here's the basic forms that you're going to use the most. Thank you for watching this. If you have questions, please get with me.